what does this 9.8 meters per second squared really mean? Well, acceleration is a change in velocity over a certain amount of time. So for every 1 second, the velocity increases by, or changes by, 9.8 meters per second. It's a change in velocity over a certain amount of time. So based on this information, for every 1 second, the velocity increases by 9.8 meters per second. What velocity does our book hit the floor? Okay, so let's think about this here. Let's do a approximation. Let's do a little estimation here. So at 0 seconds, when we drop the book, how fast is the book going at 0 seconds? Well, we're just letting go of the book. We're not throwing the book down. We're not throwing the book up. So the initial velocity at 0 seconds is going to be 0 meters per second. Okay, so based on our definition, for every 1 second, the velocity increases by 9.8 meters per second. After 1 second, what's the book's velocity? Oh, it's 9.8 meters per second. Okay, well, after 2 seconds, once again, for every second, the velocity increases by, or changes by, 9.8 meters per second. So after 2 seconds, what is the velocity of the book? 19.6 meters per second. And so what did I do there? Well, we have 9.8 plus another 9.8, or 9.8 times 2 will give us to 19.6, and that's the velocity. What about after 3 seconds? Well, 9.8 plus another 9.8 plus another 9.8, or simply 9.8 times 3 gets us to 29.4 meters per second. So in our previous problem, what I want to do here is, okay, so once again, we're going to be looking at what velocity does our book hit the floor. Okay, so we're going to be using the time that we should have gotten, not the time that we calculated. So let's actually just look at use 0.55 seconds. Okay, so just coming back over here, I'm going to do some erasing. We're not going to be using this anymore. The time that we're going to be using is our 0.55, the time that we should have gotten in our experiment, so 0.55 seconds. If we're doing an approximation over here, 0.55 seconds is between which two of these time frames over here? So we have 0 seconds, 1 second, 2 seconds, 3 seconds. Hey, you know what? 0.55 is going to be between 0 and 1. So I'm thinking, if I'm to just estimate this, I'm thinking that the velocity at which the book hits the floor will be between 9 meters per second and 0. Let's just do a little estimate here. If it's 0.55, that's roughly half. I'm just going to do this in my head right now. Let's actually just say, hey, you know what? I'm thinking roughly 5 meters per second is a good rough guess over here. So let's actually just calculate this out now. So we're interested in our final velocity. Hey, look at this. We have so much given information over here. We don't need to do our cancellations. All we have to do is come over here and say, hey, any one of these formulas that has to do with final velocity, I could use that because I have so much given information over here. We could use any one of these formulas that once again has to do with final velocity. We're not going to use this one though because that has to do with average. So we're for the most part just going to be using these formulas down here. So look at this. Final velocity is by itself already on the left-hand side of the equation. I think it would just be very easy to just use this formula because, once again, it's already on the left-hand side of the equation, just like this one, but we actually do have this squared over here, so I don't want to be dealing with that. Let's keep things simple, and keep in mind, hey, we have all of these variables. We have the final height, we have the initial height, we have all these other variables. We could really use any one of these except for this one right here, which doesn't have final velocity in it. So equation number 5 is really the only equation that we can't be using. Hey, you know what? If we were to use equation number 4, we have final velocity in here. It's going to just take a little bit more work at the very end when we're having to solve for final velocity. I don't want to do that. I just want to use the easiest one, which is this one right here. It's already solved out for final velocity. So that's the equation that I'm going to choose to use. Vf is equal to Vi plus our acceleration times delta t. Let's do our substitutions here. Initial velocity of 0 plus our negative 9.8 times our delta t, which is 0.55. All we have to do is plug this in the calculator and we get our answer. This 0 provides no value, so we have a plus negative 9.8 times 0.55, so we have negative 5.39 meters per second. Hey, our guess was pretty spot on. Well, not exactly, but pretty close. Hey, wait a minute. Once again, why is it negative? Well, what does the negative represent? The direction. Which direction is the object going? Hey, it's falling down to the ground. So the negative here represents direction. So we were able to calculate the velocity at which the object hits the floor. So once again, this is the velocity that the object, that the book, the box, whatever the case is, hits the floor at this velocity. One thing I do want to actually have you keep in mind is this. Let's come back to our kinematic equations. Like I said, you could have used equations 3, 4, or 6. Keep in mind this. When you plug in all of your values over here, the very last step that you're going to have to do is we don't care about Vf squared. We would have to take the square root of both sides of the equation. And whenever you take the square root of a number, in your calculator, you will get a positive answer. We want to make sure that we do include the negative sign to represent our direction. Try not to actually fall for things like that. If you do say, hey, you know what, the final velocity is 5.39 meters per second and in the downwards direction, maybe your professor or teacher will accept that kind of answer, but really just make sure that you include the negative sign. It would actually be more accurate if we were to say these values are negative because, once again, velocity is a vector, and vectors have both a magnitude, a value, as well as direction. So it would actually be more accurate for us to include these negatives here, including over here, as well as this, because not only is velocity a vector, but also acceleration is as well. So once again, these negatives are just representing the direction.